Hello guys and welcome to today's video. On today's video, I'd like us to focus on a new technique that we're going to introduce called integration by parts. This technique we also use it to integrate, okay? Integration by parts formula, I want to show you guys where it comes from. It's not really necessary for you to memorize how, this formula comes about, but then I think, yeah, there is fun in it, okay? So it basically comes off from product rule. Suppose you have two functions f of x and g of x that are differentiable. Then if we take the derivative d by dx of those two functions, say f of x times g of x, so we apply product rule. We know that by product rule, we first leave out our f of x, then take the derivative of g of x, then say plus. Now we leave g of x, then take the derivative of f of x, just like that. Okay, so in particular, by product rule, this is what we get. If we derive the product of f of x and g of x, we get these results on the right hand side. Okay, nice. So now what we're going to do is to try and apply the concept of what exactly is an integral. Remember that integral is basically antiderivative. We are going back. So if we are able to derive the product of f of x and g of x and get what is on our right hand side right there, then that means if we integrate what is on the right hand side, we must get f of x times g of x. Okay, so I'll just quickly write that down. So what I'm basically saying is that if we take the integral of f of x times g prime of x plus g of x times f prime of x, we expect say dx, we expect to get the product of f of x and g of x, just like that. Okay, so now let's try and separate these two terms, since there is an operation sign in between them of a sum. Then we can simply see that we're going to have integral of f of x times g prime of x, then plus integral say dx. Sorry about that, let's put our dx right there, then plus integral of g of x times f prime of x dx. Then this obviously equals to the product of f of x and g of x. Okay, so now we can just do a little bit of trick. Maybe take this one to the right hand side. So if we take that one to the right hand side, we're basically going to have what? We're basically going to have on our left side, we'll be left with an integral of f of x times g prime of x dx, which will be equal to f of x times g of x minus integral of g of x times f prime of x dx. So this guy, when we take him to the right hand side, it becomes negative, which is what I have right there. Okay, so in particular now what we have right here is the formula for integration by parts. Okay, so this formula, this is the formula that you use for integration by parts. So this formula at most, it can be a bit confusing and so forth. We can try and simplify it further. Say maybe if we let u be our f of x and we let v be g of x, then now if we take the derivative of u, we will find that du is equal to f prime of x dx, and the v will basically going to be g prime of x dx, just like that. Okay, so that is the basic idea of about the things. So now what is left of us now is to go into this formula that we have right there and substitute everything. Where we see u, where we see f of x, we substitute u, and where we see g of x, we substitute v. Where we see g prime of x, we do it like that and so forth. Okay, so now let's go and plug. So we see here we have integral. So I have my integral, I put it right there. Then it's followed by f of x times g prime of x dx, where I know that my f of x is basically equals to u. So I'm going to have u right there. Then g prime of x dx, my g prime of x dx is equal to dv. So I'm going to have u dv. Okay, so that is all on my left hand side. So this should be equals to, now what is f of x? On my right hand side I have f of x times g of x, and I know my f of x is u, so I'm going to have u, and g of x is v, so it's uv. Okay, then minus, now I have my integral sign, let me put it up there like that. Then I know my g of x is v, so I'm gonna have v then times g times f prime of x dx, where f prime of x dx is basically your du right there. So I'm gonna have v du. Okay, so this is now the formula that is in a more simplified version that you can use all the time when you are doing integration by parts. I think this is the formula we are all familiar with. Okay, yes. So was just showing you guys how we get these formulas, but then otherwise now let's get into using these formulas and see how they're gonna help us to integrate the things. So let's say for example we have integral of x e to the x square dx. So now this one, I want to show you guys that it doesn't necessarily need you to use what you call partial. What is this integration by parts? Okay, it just needs you to use u substitution. So the only time that you're gonna need to use integration by parts, you will see when exactly it's needed. Okay, and also the other thing, it will be which one is it that you have to choose as a u, which one is it that you have to choose as a v. So let me not confuse you. Let me just go by it step by step. Like I said, this one is just 2 steps, then you are done. For this one, you don't need integration by parts. You're just going to make your u to be x squared. Then you know that the derivative of the derivative of u will just be 2x dx. And then basically in a way, you can make the x subject of the formula and get the u over 2x, just like that. Then therefore this means that if we go and plug the things in there, we're going to end up having integral of, we have our x, then e to the x square, where x square is u, then times dx, where dx we know is du over 2x, so times du over 2x. Then this x and that one will cancel out. That's why I say for this one you don't necessarily need to use integration by parts, because the variables of x will cancel out when we want to use the u variable. Okay, so this basically is equal to I don't know, integral of e. So let me put out this half that comes from here. I'll put it on the side. Then we are basically integrating e to the power u du. So this is just equals to 1 all over 2 e to the u plus c. Okay, the integral of e to the u is just e to the u. Then bring back what is our u. We know that our u was x squared. So our answer to this problem is basically 1 all over 2 e to the x squared plus c. Okay, so that is the main idea of how you use substitution for this type of problem. But then now our focus for today's lesson is to use integration by parts to solve the things. So you notice that when you have here x squared and x, you don't need to use integration by parts. However, if you had x e to the x dx, now you cannot use u substitution right here. This is when you're gonna need to use integration by parts. Okay, so let's go ahead and solve this one together using integration by parts. I'll just quickly write down the formula. The formula says it's u dv equals uv minus integral of v du, just like that. Okay, so I want us to go and solve integral of x e to the x dx. So before we do that, I want to ask you guys which one now is going to be our u, because we are trying to follow this formula and we see that we need u, we need v, and we need du, and so forth. And now which one is going to be the thing, and also dv. Okay, so which one is going to be our u, which one is going to be our dv. So we need u, then we're also going to take the derivative of that, then we need dv and v. Okay, so how do we choose u and how do we choose dv? Okay, so how you choose u, basically you follow this. I'll just write it down here, liate. Okay, so you just follow this. This will help you to choose which one is your u. So this will help you to choose u. So you use this one to choose u, where L basically stands for logarithmic or lean functions. So logarithmic or lean functions, the first one L is the one that you choose first. Okay, the first that appears is the one that you're gonna choose. Say, from this example, you see that we do not have any logarithmic or lean function, so you cannot go with that. Then I basically stands for inverse trig function. So when you have the inverse trig functions, this is the second choice that you have to choose your u. Okay, then the third choice is algebraic functions. So in this case, you see that from our example, our algebraic function will be x. Okay, so that is the algebraic function that you have. So this will be our u. We're gonna choose x as our u, following this one. Okay, then t, it stands for our trig functions. And then finally e, it's the exponential functions. Okay, so in this case, our exponential function for the one that we have is e to the x. But then already we're gonna choose x as our u, so we cannot also choose e to the x as u. We have to only pick one. Okay, so following this, we see that our algebraic function, which is x, comes first. Since we choose u going that way, and whichever one that comes first will favor us. Then since an algebraic function x comes first, then we're going to have u as x right there. And we know that the derivative of that will just give us 1. So we're going to have 1 times dx. Okay, so you take the derivative of u, you just get dx. Okay, and whatever that remains now, since this is our u, whatever that remains is therefore going to be our dv. Okay, we know that x is u, then whatever that remains here is going to be dv, so it's e to the x dx. Okay, so in order for us to move from what is this, to move from a differential to the original function, we need to integrate. So if we integrate now, we're going to integrate both sides. That's how we move from dv to v. If we integrate, integral of dv is equal to v, then this side we're just gonna have integral of e to the x is e to the x, like that. Okay, so we have everything that we need. So now that implies that the integral of x e to the x dx equals, what is your u? Following the formula, it's supposed to be uv. U, we know that it's x, and our v, it's e to the x, then minus integral of v, where v is e to the x, then times du. Du is just equals to dx. So that is how we go about the thing. So now we get that we have x e to the x, then minus the integral of e to the x is just e to the x, then plus c. So now this is the final answer to that problem. So I hope that the insight that I tried to get you guys through, it was really helpful, and it broke down things that maybe were confusing to you. So on the follow-up examples, just bear with me. I'll try and accommodate you and make sure that I go through every step. And I'm not gonna go again explaining everything. We're just gonna follow the same things that we were doing right here. Okay, we're just gonna follow everything that we were doing here. And yeah, let's move on to the next example. So let's say maybe you want to integrate, say you want the integral of ln x dx. So the integral of ln x dx, following the LIATE, we see that the first letter L that accommodates log function or ln is the one that is going to be our choice of u. Since it's the first letter there, that means we have to choose ln x as our u. So that means now we have u as ln x. So if we pick u as ln x, what is going to remain there? We already chose this. So what is remaining is just dx. Okay, so that will be our dv. So dv equals dx. So if we integrate this one, we're going to get that v equals to x. Then the derivative for this one, we need the derivative. If we take the derivative, we will get 1 all over x dx, just like that. Okay, so since we know the formula says uv minus integral of v du, then it implies that integral of ln x dx is therefore equals to u, which is ln x, times v. So I can put the x at the front like that, since v is x. So this is my uv, then minus integral of v. V is x. Then it says v du, where I know my du is 1 all over x dx. Okay, so times 1 all over x dx. So basically I have x ln x minus integral of, notice that this x and that one will cancel out. So I basically have integral of dx. So this is x ln x minus x, then plus c. So this is the final answer to this problem. So the integral of ln x dx is x ln x minus x plus c, just like that. So you see how easy it is to use integration by parts if you know what you have to do. So let's move on and do other problems. Say maybe you are given something like, I don't know, integral of arcsine x all squared dx, just like that. So for this one, what are you going to do? How are you going to solve the thing? You also have to use integration by parts, or you can use, sometimes it is allowed to use u substitution. Then after you use u substitution, you therefore use integration by parts. You can use two techniques in one problem. Okay, this one, it doesn't need you to use two of them, but then even if you do use two of them, it will still work out proper. You can just kill it right away with using integration by parts alone. But then I would like to take you guys through the route where we use u substitution, then come back and use integration by parts, just for the insight that it is allowed to use both techniques in one problem. Sorry. For as long as you're not doing any illegal stuff. Okay. So in this case, I'll let my function, inner function, arcsine x to be my u. So this will be u equals arcsine x. Okay. So if my u is arcsine x, remember that I'm allowed to take sine to that other side. So I'm allowed to take this to that side. So if I do that, I basically get x is sine u. So if x is sine u, then that is the thing that I can do with that. So for so long, then from this one, I'm going to draw a right angle triangle. Remember that sine is opposite over hypotenuse. So my angle is u, so I'm going to have u right there as my angle. Then it's opposite, my opposite is x over hypotenuse. So this is the same as over 1. That means I have 1 there. And if I try to solve for the adjacent side, I'll end up having 1 minus x squared, just like that. Okay, so this right angle triangle might look like it's useless, but then it's going to be very useful as we proceed with our problem. So now coming back to the substitution that we made, remember now we are using u substitution, then we're going to get to integration by parts. Then here we can say that the derivative is 1 over square root of 1 minus x squared. The derivative of arcsine x is 1 over square root of 1 minus x squared, then dx, just like that. Therefore, from here you can try and make dx subject of the formula, and if you try and do that, notice that dx will just be, you cross multiply, it will be square root of 1 minus x squared, then du. Okay, then now since we have everything that we need, we can go back and substitute into our integral. So we have integral of, we know that arcsine x, we let it be u. So when we see arcsine x, we put u, so it's u squared. And when we see dx, we plug the square root of 1 minus x squared du. So we're going to have times square root of 1 minus x squared du. But then now, when we are at this stage, see that we are trying to work with the integral of variable u, but then we have a problem. The variable x is still there. But then how can we get rid of that x? Remember, we know that x is basically equal to sine u. So we can plug it there, sine u. Okay. So this is equal to integral of u squared times square root of 1 minus sine u squared, then du. And we see under the square root there is an identity. That identity 1 minus sine square u is cos square u. Then under the square root it will just become cos. Okay, so you're basically going to integrate u square cos u du, just like that. Then when we are here now, that is when we're going to start to use integration by parts. When we are here, we need to use integration by parts. So notice we have used u substitution, and then now in between solving the problem, we get to a point where we start using integration by parts. So if we are going to use integration by parts from this step, the thing that I'm going to need is the formula. I'm going to write it here. Integral of u dv is equal to uv minus integral of v du. So I need to pick my u, and whatever that is remaining is going to be my dv. So which one is going to be my u? Or you can use, in this case, since you already have u, we can use a different variable k. It's still fine. Okay. So if we're going to use a different variable k, I will say this formula, maybe for those who might get confused, it will look something like this. I'm just going to change u to k. So we're going to have integral of k dv equals k v minus integral of v dk. So this is the formula that we're going to use. It's still the same formula. I just changed to a variable of k since we already have a u right there. Okay. So now, following LIATE, notice that we have an algebraic function first before the trig functions. Here we have an algebraic function and a trig function. And the one that comes first is this one. That means we're going to let this one be our k. So in this case, k will be u square. Okay, then the derivative of that will give us 2u. Okay, so if we pick k, we pick our k to be u square, we pick it at this one. So whatever that is going to remain, it will be dv. That means dv will be cos u du. Okay, so let's quickly work with that. So we know that dv is cos u du. Then remember, here we take the integral to get v. If we integrate, we get v. So the integral of cos u is sine u. So don't make the mistake of saying it's negative. So it's going to be sine u, just like that. Okay, so therefore, the integral of u square cos u du is the same as, now it's kv, where k is u square. So we're going to have u square sine u, then minus integral of v. What is v? V is sine u, then times dk, where dk is 2u. So I can put the 2 outside right there, then say times u, then du. So I forgot to put du right there. So there has to be du. Fix that. Then now from here, we're gonna have u square sine u, then minus 2 into, now the integral of this one also needs us to do integration by parts. So now we're gonna do integration by parts 2 times. Okay, so every time, since we're solving this problem here, every time when you see something like that and it's an algebraic function with the power of 2, know that you're going to do integration by parts 2 times. If it was the power of 3, then we are going to do integration by parts how many times? 3 times. Okay, so that is the basic idea. So let's do it again now. So we're trying to integrate u. I'm just rewriting what I had initially in a more arranged order. So now we can integrate, say, u square sine u, then minus 2 into, using integration by parts again to solve the integral of u sine u du. What is this going to be? We still follow the same procedure. We can use another variable z. It doesn't matter. We can use any other variable. We're gonna let z be u. Then whatever that remains will be our dv. So we know that the integral of sine u will be negative cos. So we're gonna have minus u cos u, then plus how I get a plus is that the formula comes with a negative. So also I already have a negative that comes with the integral of sine u. Okay, then this becomes positive. Then I have to integrate cos u. So the integral of cos u, which is just going to be sine u, just like that. So feel free to pause the video and do this integral on your own and see if ever you're gonna get the same answer as me right there. Okay. Then now we have u square sine u minus and minus will be plus. So here we're gonna have plus 2u cos u, then minus 2 sine u. Okay, so now this is the answer that we get. Once we are here, we are at the last step. So you can say plus c. But then initially the problem that was given, it was in terms of x. Okay, remember that we are integrating x sine x squared dx. So now this is when this right angle triangle that we drew is going to come into play and be really helpful. Okay, so remember, I'm just going to write on this side here. We know that x is sine u. This is how we got the right angle triangle, and we got it where our angle is u. Since it's sine, we know this is x. Opposite, then hypotenuse is 1, then we have 1 minus x squared, just like that. So we can go on and substitute the things on the thing. Okay, so what is u? U is arc sine x. If we take sine that side, it's going to be arc sine x. So we have and we know that sine u it's x. So we can say we have x then times u, which is arc sine x all squared, then plus 2u. What is u? U is arc sine x. So arc sine x times cos u. What is cos of u? We go to our right angle triangle. We know that for cos we have adjacent over hypotenuse, then times square root of 1 minus x squared, just like that. Then minus 2 sine u. Sine u is just x. So we plug x right there, then plus c. So this is basically your final answer. X arc sine x all square, then plus 2 square root of 1 minus x square times arc sine x minus 2x plus c. Okay, just like that. So this is the final answer to that problem. Okay, so it just needs you to think a bit. It doesn't really need anything new that you have to do right here. It's just mathematics and algebra. For as long as you know how to apply the technique of integration by parts, you're gonna get to the final answer as easy as that. Okay, so I'd like us to look at another problem together. And if maybe you are lost in between when we are solving this problem right now, feel free to rewind the video and go through every step again, and also try it on your own and see if you can get this similar answer that we got right here. Okay, let's proceed and see if ever we can do more examples. Say maybe you want to integrate I don't know, say integral of maybe you have ln x all square divided by x to the power 3 dx. Okay, so if you have something like that, now what do you do? How do you solve such an integral? Also for this one is going to be an integral that you have to solve using both techniques. There's u substitution technique and the integration by parts. Okay, so let's go through it and see how can we do it and quickly get to the solution. So first, you're gonna let u be ln x. So u is gonna be ln x. So if u is ln x, then dx is going to be what? Dx is going to be 1 all over x. I mean du, this side has to be du, sorry about that. The derivative du will be 1 all over x dx. So in particular, if I make dx subject of the formula, I just cross multiply dx will be x du, just like that. Okay, so now let's go and plug the things on the thing right there. If we plug the things, we're going to end up having integral of, where we see ln x, we put u, so we have u squared all over x to the power 3. Then what is dx? Dx is x du. Okay, so Now notice that this x will cancel one of the x in there, so you're basically going to end up having integral of u square all over x square du. As I was saying, we still have a variable of x where we need to integrate in with variable of u. So how do we get rid of this x right now? Okay, do we have a relationship between u and x? Yes, from the substitution that we made, u is ln x. So if we want to make x the subject of the formula from here, notice that x is basically e to the power u. Okay, so if we take e both sides and we raise everything to e, we're gonna get x as e to the power u, like that. So we can replace x with e to the u. So basically, we're gonna end up having uh, integral of u square divided by e to the power 2u. Okay, where the 2 comes from the power that was already there. Okay, then du. And I can rewrite this now. Take e to the 2u up there. So I have integral of u square e to the minus 2u du. So now I have to integrate u square e to the minus 2u du. This is when I have to use integration by parts now. Firstly, we use u substitution. Then as we proceed in solving the problem, we get to a point where we need to use integration by parts. You don't get here and be like, I'm stuck, okay? Because yes, it is still possible for you to solve this problem. There is a technique that we just, went through together today, and we are still going to utilize it to help us solve the problems. So if we're going to use what is this integration by parts, in this case, I'll just write the formula with a different variable. I can choose k again and say integral of k dv should be equal to kv minus integral of v dk. I just replace u with k because already I have used u from when we were using the u substitution. Okay, so now what is going to be our k? We need k. Let me change the color. We need k. K is going to be our algebraic function. So k will be u square. So the derivative of that will be 2u du. Okay, then if k is u square, what is remaining is it will be our dv. So in this case, our dv is e to the minus 2u du. Okay, so dv equals e to the minus 2u du. Okay, so now v is basically going to be equal to the integral of this. The integral of that is what you call minus 1 all over 2 e to the minus 2u, just like that. So this is our v. This is our v. Okay, so now let's go and plug the things on the thing. So therefore, it implies that the integral of u square e to the minus 2u du is equal to kv. K is u square. K is u square. And v is minus 1 all over 2 e to the minus 2u. So I'll have minus 1 all over 2 u square e to the minus 2u, just like that. Then minus, according to the formula, there is a minus there. Then integral of v. What is v? V is minus 1 over 2. So you can say that negative will affect the negative from the formula, then it becomes plus. Then I take the half outside, the half of a constant outside. Then integral of e to the minus 2u. So I took out this half from v, which is there. Then I just put e to the 2u. Then what is dk? dk is 2u du. So I have to say multiply by u du, where the 2 now will come out like that, and it will cancel with this one. So they will cancel out nicely like that. So basically, I have minus 1 all over 2 u square e to the minus 2u. Okay, then I don't know, plus integral of u times e to the minus 2u du. Okay, so even now here we have to use integration by parts again. Remember I told you about what I told you about the power right here, the power of an algebraic function, u square. It will imply we have to use integration by parts twice. So this is the second time we are using it. Firstly, we use it here. Then now we are on this step, we have to use it again for this part. Okay, So let's quickly do that. I'm gonna quickly do it, then you can just confirm if you get the same answer as me, so we don't waste a lot of time. So we have minus 1 all over 2u square e to the minus 2u, then plus. Now here I'm gonna choose my thingy as what you call my KSU, then whatever will remain is my dv. Then this will mean that my v will become minus 1 over 2. So I'm gonna have minus 1 over 2. Let me try and write that in a needy way. So I'm gonna have minus 1 all over 2 u e to the minus 2u. Okay, then plus. Now it's gonna become plus because of the negative that will come with the thing. So plus 1 all over 2 integral of e to the minus 2u, integral of e to the minus 2u, then du, just like that. Then this is equal to 1 all over 2 u square e to the minus 2u. Then say minus 1 all over 2 u e to the minus 2u. I'm writing this term. Then now I'm finally on this one. So this one will become minus 1 over 4. The integral of this will be minus 1 over 2 e to the minus 2u, then multiply with this half. It becomes minus 1 all over 4 e to the minus 2u, then plus c. So we are almost at the final answer. We just need to bring back what was our u. So let's go and check what was u. U was ln x. So we just plug the ln x. So this is basically going to be equal to minus 1 all over 2 ln x square. Then I don't know for this one, what is it gonna be? If we plug ln x here, then we're gonna end up having x to the power minus 2. Okay, yes, it's gonna be x to the power minus 2. Then say minus 1 all over 2, then u, what is u? U is ln x, then times, also for this one is gonna be x to the minus 2. Then minus 1 all over 4 x to the power minus 2, then plus c. Then now I can write my final answer in a more neat way. So I'm gonna have this okay, there is a power of 2 right there. I thought these two terms were like terms, but they are not. Then we have minus 1 all over 2 ln x all square divided by x square minus 1 all over 2 what did I just say? Let me just do this. Say minus, we have minus ln x all square divided by 2x square. I can write it like that. Okay, then minus ln x over 2x square, then minus 1 all over 4x square plus c. So this is my final answer like that. Okay, so yeah, thank you very much guys for watching. We have come to the end of the video, and stay tuned for more tutorial lessons and the insight that you're gonna be getting from my videos. I appreciate the support, and see you guys on the next video.